Hello, I'm Mr. Mailer, your online math teacher, and welcome to my channel. Today we're going to be talking about how to solve for missing side lengths in a right triangle using the Pythagorean Theorem. So today we want to talk about not only what does the Pythagorean Theorem tell us, but when can we use the Pythagorean Theorem. So let's start off with what the Pythagorean Theorem says. So the Pythagorean Theorem says for right triangles, just as pictured here on the left, if you take each of those legs, A and B, and square those lengths and add them together, you will get the same number as if you square the length of the hypotenuse. So that's where you get this phrase a squared plus b squared is equal to c squared. Now, I will often instead say leg squared plus leg squared is equal to hypotenuse squared, because that it's not always a given that your leg lengths and your hypotenuse lengths will be called A, B, and C. In fact, sometimes you might use those letters to label one of the legs. It all has to do with personal preference. So now let's jump into looking at a couple examples and deciding when we have enough information to use the Pythagorean theorem. So as you can see here, I have three different triangles. So we want to investigate the different aspects you need to use the Pythagorean theorem. The first thing is we know the Pythagorean theorem only works when you have right triangles. So we see that both the first two triangles are right triangles. So we satisfy this. This third triangle here is non-right. So that means that we cannot use the Pythagorean theorem here. So that is a negatory. We cannot use it for this third non-right triangles. We can't use it for. The second piece of information is, do we know two side lengths? So do we know two side lengths? And the answer to that question is, for this first one, no. The only side we know here is 3. That's not enough information to use the Pythagorean theorem, so we cannot use it to solve for side lengths in this triangle. But the middle triangle, we do know that we have a leg of length root 2 and the hypotenuse of length 7, so yes, we can go ahead and use the Pythagorean theorem in this problem. So now that we've talked about identifying when you can use it, let's look at a couple examples where we solve for missing information, missing legs using the Pythagorean. So now let's look at this example where we know two side lengths of my right triangle. So in this case, I know both leg lengths. They are 5 and 4 in this case. So what that means, I can start off by writing my Pythagorean theorem to say this first leg of 5 squared plus that second leg length of 4 squared should be equal to my hypotenuse squared. So this gives us 25 plus 16 is equal to c squared. And then if I add my 25 and my 16, then I am going to get myself to 41 is equal to c squared. And in this case, I know that the square root of 41 is now equal to c. I know 41 is a prime number. I know nothing is going into it, so that this is the final answer. I have solved for this hypotenuse length with the Pythagorean theorem. So now let's look at one more example. So in this example, we now know one of our leg lengths and the hypotenuse length, but we don't know the length of that second leg. So to be able to set up the formula this time, I'm going to have a squared as my unknown plus b squared, and b is length 6 here, so I'm going to plug that there, is equal to c squared. That is 10 squared. Notice how I'm always putting parentheses around my numbers. I would recommend do this out of good habit, because sometimes when you have square roots in them, you want to make sure you square everything in the side length and not just a square root. So now if I go out and expand this, I have a squared plus 36 is equal to 100. Now I can subtract off my 36 from both sides to get a squared is equal to 64. So that means that a is going to be equal to the square root of 64. Now, notice that I typically tell my students that I want these answers in simplified radical form. So what that means is we need to ask, hey, can we simplify the square root? Now, you might notice right off the bat that the square root of 64 is actually 8. So in reality, I already know the answer is going to be 8, but say you don't remember what this simplifies to. You can always make a factor tree to figure out what you can pull out, because anything that is paired can be pulled out of their square root. So I could quickly do that by recognizing 64. In worst case scenario, I don't recognize 8 goes into it, so I can always, when I have even numbers, pull out 2. So I could say 2 and 32, continue this pattern where I break down 32 into 2 and 16, 16 down into 2 and 8, 8 into 2 and 4, 4 into 2 and 2, and then I can see I have 1, 2, 3 pairs of 2's, so that means that if I look at the square root of 64, I can pull 3 2's out front, and since there's nothing left, I will have nothing left inside my square root, so that just goes away, and then I get myself to 8. So this is another way I can do this. So I hope you found this video helpful. This is about all there is to using the Pythagorean theorem, and I hope to see you again soon.